The Hearable for the smart industrial workplace.
Welcome to today's presentation. My name is Jan Rennies and I'm a hearing researcher at Fraunhofer IDMT in Oldenburg. After this stream, I'm happy to welcome you to our Q&A session. But first, let me give you some insights about the smart hearable for industry workplaces of the future. For my presentation, I will be assisted by this colleague of ours, who is actually an artificial head. That means that at the places where humans have their eardrums, this artificial head has two microphones, which allows us to record audio in a way that's very natural, and we can play it back as if I were standing right next to you. So let's try this. Now we've switched the audio, and you are hearing what my colleague here is hearing. And if you're listening with stereo headphones, you can hear that my voice comes from the right side because that's where I'm placed. Now that's not entirely true. You're not hearing what the head hears, but what is processed through these small devices that we put in each of the two ears. This is our hearable research prototype, the so-called acoustically transparent earpiece developed in the Cluster of Excellence Hearing for All. This device is a very handy research tool for us because it has two microphones on the outside, which can record audio close to the entrance of the ear canal, and another microphone on the inside. And with this combination of microphones, we can do many things with the audio, as you will see in the future demonstrations in a couple of seconds. Normally, when you plug something in your ear, it will seal your ear canal. That's good for hearing protection, but it also affects the way sounds from the outside arrive at your ears. And this can make sounds potentially unpleasant, unnatural, or even unintelligible. Let's illustrate this. We will now switch off the processing of our hearable altogether, and this will put the device into its passive damping mode. What you're hearing now is my voice, which is probably quite difficult to understand, even if I go very close to your ear and shout into your ear. So let's switch it back on again to give you a better hearing experience. What you just heard is similar to the effect that hundreds and thousands of workers experience every day when they put passive hearing protectors into their ears. And as you can see, this would prevent them from communicating with their colleagues. And we don't want this. So we are working on technology that can make sounds to be processed naturally when you talk to a colleague. Now, why do we care so much about natural hearing? Because we believe that any smart hearable should not only introduce new features, it should also disrupt your natural way of communicating as little as possible.
Binaural cues.
For example, we try to make sure that you can still hear all the information that you could hear without our hearable when you have it plugged in. This is not only important for speech communication, it's also important for remaining in touch with the acoustic environment. At industry workplaces, for example, it's important to detect critical sounds around you. You have to detect what's happening and where something is happening, especially when you wear hearing protection, because normally when you don't have anything in your ears, you can detect sounds, and that's because you have two ears, and the sounds that arrive at these two ears differs depending on where the sound comes from. A sound from the front will arrive at the same time at both ears and will also be equally loud, whereas the sound from the right arrives earlier in this ear than at the other ear. And these tiny differences in level and in time can be used by the two ears to detect where sounds are coming from. Now, many modern hearing protections process the sounds independently at the two ears, and they disturb these tiny differences, making it very difficult to detect sounds which can possibly be dangerous in industry workplaces, for example, when you cannot hear where an alarm sound is coming from. Now, when you listen with stereo headphones, you will be able to follow the clicking noises here, which is because we make sure that all these information and the differences between the two ears remain intact even after all the signal processing that we apply.
Smart damping.
So now we have a device that allows you to communicate naturally to your colleagues. It also gives you access to the information at the two ears so that you can orient yourself. But in industry environments, of course, it's important that your hearing is also protected from very loud sounds. Remember that we are processing the sound that arrives at the microphones so that it is transmitted naturally to the inner side of the device. That's not entirely true, however, only for sounds such as my voice, which are not dangerous to you. When the sound that's arriving here is too loud, we can apply a limit as to what level we allow to arrive at your ears. We call this smart damping. So when I produce a very loud sound now, what you actually heard was this whistle, but attenuated so that its output level would not be harmful to your ears. And when I talk now, you can hear that it's a natural hear-through again. So this device allows you to transition between hearing protection from loud sounds and communication with your colleagues at comfortable speech levels.
Individual hearing support.
So we've seen that we can do audio processing to improve communication. But what if you have a hearing loss? In Germany alone, this affects more than 10 million people, and most of them don't have a hearing aid. And even if they have, the hearing aid might not work well together with hearing protection at work. So we are working on technology that allows you to get hearing support and can be integrated directly into the smart hearable. So that, by means of an easy interface, you can tune the sound to your individual needs. For example, an interface like this, where you just move a dot and you can feel how the sound changes and just explore this area here and see where you like it best. And that's where you stop. So when I keep talking now so that you can hear the difference, you might like this position best, and that's just where you stop. You don't even need to conduct a hearing test for using this individual hearing support. In fact, you don't even have to know that you're hearing impaired at all. And scientific studies show that such technology is not only beneficial for hearing impaired, but it's also beneficial for people with perfectly normal audiometric hearing, for example, when they are in a stressful environment or when they just want to address their personal needs. We believe that individual hearing support and sound personalization can be a strong driver for making communication at workplaces more efficient, safer, and also raise acceptance of hearing protection devices.
Selective hearing and voice filtering.
Let's now move one step closer to real industrial applications and consider another fascinating research topic, that is selective listening. In industry environments, you're usually exposed to a lot of noise, such as this, which is now played back through the loudspeakers around you. Depending on how close you are to the noise sources and the person you want to talk to, like your colleague, this noise can be very loud in comparison to the voice that you want to listen to. And at some point, you want your smart hearable to apply denoising, that is, the noise reduction, to suppress the noise and make the voice stick out much better. And if we switch this on, you will hear that my voice is now much better intelligible. Thanks to modern machine learning advances, we can do much more than just suppress such a relatively easy stationary noise. So let's listen to another example. Let's hear some music. In contrast to the factory noise, music is much more instationary. You hear the beats, you hear the drums, you hear the complex rhythms, and still we can apply so-called source separation algorithms, which have been trained on large amounts of data and which can filter out voice from backgrounds such as this music. Now, of course, music is not what you're usually listening to in industry environments, but the great thing is source separation also works for industrial noises, which can be very loud and very annoying. For example, such a metal grinder. Imagine I'm your colleague and you want to talk to me standing next to this metal grinder. If we switch on source separation now, we can extract my voice and we can remix it with a softer version of the metal grinder so that my voice will stick out much better, and still you can hear the machinery around you, which is important to stay in touch with your environment and to be aware of what's going on around you. These source separation algorithms based on machine learning can be trained to perform very specific tasks. For example, to filter out a voice from a mix of voices. Imagine me talking to you and there's another person standing right next to me talking at the same time, like now.
Peter got
when I keep talking now, you will have difficulty focusing on my voice because there's another male talker right next to us talking at the same level. Now we can apply so-called voice filtering algorithms, which have been trained on just a few seconds of my own voice, which we can now apply to extract my voice from this mix. You will agree that my voice is now much better intelligible, and you can much better focus on it than before.
This voice filtering leads to a whole new world of possible applications, which are also relevant for industrial applications, as I will show you in a second.
Voice control production and documentation.
Of course, we can use the microphones built into the Smart Hearable not only for communicating to your colleagues, but also for sending spoken commands to the machine you're working with or the production system. Such is shown in this short video clip.
Maschine, Licht an.
Befehl Licht an wird ausgeführt.
Maschine, Bauteil 1, laden.
Befehl Bauteil 1 laden wird ausgeführt.
Maschine, Job starten.
Befehl Job starten wird ausgeführt.
Maschine, Bauteil 1, entnehmen.
Befehl Bauteil 1 entnehmen wird ausgeführt.
Maschine, Licht aus.
Befehl Licht aus wird ausgeführt.
There are many industrial applications in which voice recognition can play a role. For example, you can avoid unnecessary walking distances between your current position and the position of the control panel of the machine. You can give a control command to the machine even if your hands are occupied, or you can facilitate documentation processes. In all these applications, it's of course relevant that only an authorized person can control the machine you're working with and not the colleague standing next to you. And this is where the voice filtering we showed before comes into play, because we can make sure that the machine only accepts commands from the authorized person. Of course, in such conditions, it's important that the data, the spoken commands and the documentation are safe. So our speech recognition engines work without cloud services, so that all the computing happens either on the device or on a server that's on site. So there are no data privacy issues here.
Advantages of in-ear microphones.
Of course, in order for automatic speech recognition to produce a real value in industry workplaces, the accuracy has to be extremely high. And that's a very big challenge in loud industry environments. But here, our Hearable prototype has another great advantage. Remember that it also has a microphone on the inside. And you can imagine this microphone to be behind the hearing protection, which basically means that all the noise from the outside will be much softer at this microphone, while the own voice is still very loud, at least in the low frequency region. In other words, the speech-to-noise ratio is much better on the inside microphone than on the outside microphone. We are working on automatic speech recognition technology which can make use of this inside microphone advantage and produce high accuracy also in very loud environments. And to illustrate what advantages this can bring and how we can use this also for human-to-human communication, I will switch on these devices now myself. So what we are going to show you now is how this can be used to improve communication between people by connecting smart hearables between different colleagues.
So right now you're hearing my voice transmitted through the air, processed by your device, and then played back into your ear. When we play back some noise now, you will hear that it's becoming more difficult to follow my voice. And it could easily be, if I move further away now, that you could no longer understand. One way to help this is to use these smart hearables as a classic headset. So now you're hearing my voice recorded on my hearable, on the outside microphone, and then transmitted to your hearable and played back as in a normal telecommunication scenario.
But even that might not be enough when the noise level around you is very high. So we are now switching to the inside microphone of my device. Welcome into my ear canal. You will hear my voice to sound rather muffled, like my head was in a barrel, and that's due to the occlusion effect, which no longer allows sound to escape my ear canal, which it normally could if I didn't have this hearable in my ear. However, you will also notice that the outside noise is now much softer than before, so the speech-to-noise ratio is much better. And we are working on technology which exploits these inside microphones and enables you to communicate in very loud environments. One particular class of technology we're working on is to make these sounds sound more nicer and more natural, to get rid of this muffled sound. So when we switch on these kinds of algorithm now, you can hear that the noise is still rather low, but the voice sounds more natural at the moment. Of course, when you do this, you have to take care of noises that can occur inside the ear canal. And that led to some rather unexpected challenges that came up. For example, listen to this. This is me chewing a cookie. So yes, we're now also working on technology to suppress cookie chewing sounds.
Weite data recording.
The ear is in fact a very good spot to put sensors, and many hearables in the consumer market already measure your heartbeat, your respiration, how many steps you take and how you move. And our team is working on adding electroencephalography, or EEG, to this sensor data pool. By measuring brain activity, EEG allows you, for example, to estimate how stressed a person is. And we want to explore how we can use this to prevent mental overload and subsequent accidents in industry workplaces. It's certainly a long way until EEG is market ready still, but the times when EEG required you to wear a full cap with a lot of wires attached and didn't allow you to move in order to get good signal quality are certainly over. Rather, people are working on much smaller systems such as this secret, which can be placed behind the ear and which allows you to record signals while people are doing their daily business. All it needs basically is an amplifier which you can wear wirelessly and which transmits the signals to, for example, a mobile phone. By using such technology, we want to make the hearable of the future smarter and smarter and hope to provide solutions that can help monitor the health and well-being of the workers in industry applications.
Our message to you.
In summary, there are many possible innovations that come up when you think about what a smart hearable can do in industry working places of the future. We are working on technology to help you document your work better using voice recognition, to control your machines, to improve communication between people and machines, and to integrate smart sensors that help monitor the well-being of the worker. I hope you enjoyed the presentation and I look forward to receiving your questions in the subsequent Q&A session. Bye-bye.